everyone. My name's Dana. I'm a postdoctoral research associate in the Todd Group at University College London. I had some technical difficulties with my lightning talk at the Creative Commons Summit, so hopefully you can find us on YouTube. I'll be talking a little bit about open source malaria and our open approach to developing new medicines. So first of all, I just thought I'd take a minute to explain what I mean by drug discovery. This can be a really long process. It's highly multidisciplinary and it encompasses everything from basic biological research to identify a target up through screening small molecules, for example, optimizing those small molecules and taking them through to clinical trials. Currently, this is typically done by for-profit pharma companies. And it is a very closed process. So what we at Open Source Malaria are doing is trying to make that process open source. So I think a good way to explain sort of what that means is captured by the 6 laws of open source drug discovery, which were laid out by Matt Todd in his 2019 paper. So first of all data and ideas are freely shared. We typically make sure that any discussion and data is in the public domain. Anyone may participate at any level. So we really try to ensure that there are as few barriers to participation as possible. Thirdly, there will be no patents, and that's simply because in order to file a patent, you cannot have disclosed anything about the project in the public domain previously to filing. So that's sort of incompatible with conducting the project in an open way. Fourth, suggestions are the best form of criticism. So we really try to foster a constructive environment for all of our projects. 5, public discussion is more valuable than private email. Again, making sure that everything is in the public domain and the discussion is accessible to anyone that wants to participate in the project. And finally, an open project is bigger than and not owned by any given lab. So it really is very, very collaborative. And why would we want to do it this way? Well, first of all, we think that it's a good way to find an effective solution quickly because you can recruit participants with a diversity of experience. So for example, with open source malaria, we've had, highly experienced pharma scientists contribute to the projects, and we've also had, groups of undergraduate researchers making great contributions. Second, you can avoid duplication of effort by openly sharing approaches, including failed approaches. So obviously, if you sort of fail in the open, that prevents people from, going down the same road twice and repeating experiments that don't work. And also, an open approach can work really well to address problems, particularly in drug discovery, that are not well served by a patent model. And so a lot of our projects focus on infectious diseases like malaria that suffer from this very problem. So how it works in practice, there are a few tools that are really important to helping us do that. Electronic lab notebooks are an open record of every experiment that's conducted on the project. They are updated in real time, and like I said, anyone can access them and see what we're doing, why we did it, and what the results were. We have found GitHub to be a really useful platform. The issue tracker sort of serves as a rolling to-do list for the project. We update the wiki, and we also use it as sort of a data repository. We recently have started doing open project meetings over Zoom, so anybody is welcome to come and participate in those. They're recorded and we put them on YouTube. So if anybody wants to catch up, they can do that. The funding and licensing, so a lot of the work is done by academic research group, which are funded by grants. We've also received many in-kind contributions from companies like Pfizer and GSK. The licensing, so our default license is a Creative Commons license. So it's not really tailored necessarily for all of our specific needs, but it does in general communicate that any outputs of the OSM or any other open source drug discovery projects are meant to be openly shared and distributed. So these are just a few highlights from the open source malaria project, which is one of our longest running and biggest open source drug discovery projects. So I've just highlighted two of our most recent publications in the Journal of Medicinal Chemistry and the Journal of Organic Chemistry. We hosted a modeling competition, so that's brought in a lot of computational expertise and some artificial intelligence approaches to drug discovery. On the biology side, we've identified some new targets in malaria that are, of interest for future research and future drug development as well. So if you want to get involved, here's all the contact information. Open source malaria, like I said, is one of the longest running open source drug discovery projects thus far. We also are actively involved in open source antibiotics and open source mycetoma research. They all have GitHub repositories with a wiki which tells the story so far, and issue pages, which is where a lot of the discussion happens. The projects all have Twitter pages that we are updating regularly, and of course you can contact me on Twitter or email if you would like to get involved in any of these projects. So thanks again for inviting me, and sorry I couldn't give this talk live, but it's a really cool project, and I'm glad you've taken the time to check it out.